All right, guys, so are there any questions on any of the homework assignments thus far? Any question over any of the assignments thus far? All right. So, we've gone over a few ways to solve quadratics. And most of the time, there's a few exceptions, but we want to get the quadratic equal to 0, and then we can solve from there. And one of the methods we've done so far is solving these quadratics by factoring. And that's what we did in 3.13. We got them factored, set them equal to 0, and solved. Because when a polynomial is equal to 0 in factored form, we can use the zero product property. And what we're looking at 3.3 is solving them by graphing and using the square root method. These are the two methods we're going to be looking at in 3.3. Now the first method we're looking at is solving these equations by graphing. And whenever we graph them, we want it to be equal to 0. We want the equation equal to 0. And for this here, x squared minus x minus 6 is equal to 0, so we can graph it. And normally when we graphed an equation of a line, we needed 2 points. And when we graphed an equation of a parabola, one of these here, we needed 5. Because we needed 1 point for the vertex and then 2 points either side, so we can get an idea of this U-shaped graph. Now with the axis of symmetry, well, we know any point to the left and right is going to be mirrored, so we really needed 3, but 2 of the points to the right or to the left of the vertex gave us the other 2. Now, for us in here, we don't have to do that. We can use the graphing calculator. Because if we grab the graphing calculator and turn it on, the first thing we can do is hit y equals, because if we plug the equation in here, it'll let us graph it. So we can type the equation in. So let's type the equation in. So our equation that we're typing in is going to be x squared. So we can get x by the button next to alpha minus x minus 6. So we can type it in. We don't need the equals 0, but we can type it in. Because when we try to solve this by graphing, or any method, we're trying to find out what value of x is going to make the function equal 0. And when we graph it, we're trying to find the x-intercepts. We're trying to see where the y value is 0. And once we type this in, we can hit graph. So we get this here. Now we can see that there's 2 points where it does cross the x-axis. And some of these might be easier to see or understand what the numbers are than others. But where we can also look is second graph, which will pull up a table. And again, we're looking for the x-intercepts. We're looking for where the y value is 0. And we do have 2 of them. Because at -2, the y value is 0. And at 3, the y value is. So the solutions for this are -2 and 3. Because again, we only really are concerned with where the y value, what value of x is making the y value 0. So our solutions for this here is x is equal to -2 and x is equal to 3. Because these are the 2 values that make the function equal 0. And in all quadratics, we're going to have 2 solutions. They might not be unique solutions. They might not here. -2 and 3 are unique. They're 2 different numbers. Because we can have some where the solution is 4 and 4, where it's the same number, but we still have 2 solutions. Now, if we wanted to check this, we could plug it back in, say 3 squared minus 3 minus 6. Well, 3 squared is 9, minus 3 minus, well, 9 minus 3 is 6, and 6 minus 6 is 0, so it works. We could do the same thing with -2. -2 squared minus 2 times -2 minus 6. Well, negative 2 squared is negative 2 is plus 2 minus 4 plus 2 is 6, and 6 minus 6 is, so they do work. They both give us a value of 0 because that's what we're looking for. So these two here are our solutions. Questions on any of this here? Are you ready for the next one? Okay. Why? For any of these here, we need this equation to equal 0. So we can subtract 4x from both sides, which will tell us that this is 0. So we have negative 2x squared minus 4x minus 2 is equal to 0. Now when we type this in, so we can go back to the graphing calculator, so we can hit y equals to pull this out. Now we can clear it out so we don't have anything there. Now for negative 2, we need to actually type negative 2. X squared minus 4x minus 2. So, any questions on how we type this in? If there's not a number or something in front of the first term and it's negative, we'll use the negative. Now, if we're actually subtracting, so in front of the 4x, we would use the subtraction. In front of the 2, we would use the subtraction. If you use the negative, it's thinking that you're multiplying. And we hit graph. So it looks like there's 1, yes? And we can check it by doing second table. So we do have one spot where it is 0, yes? At negative 1. And that's the only spot we have. Now, this here, so we can say x is equal to negative 1. That would be our solution. Now, again, I said that every quadratic has 2, and it does. The other solution is x is equal to negative 1. The answer is twice. Because anytime the graph touches the x-axis but does not cross it, it has an even multiplicity. The number of zeros there is an even amount. So here, the number of zeros that we have at negative 1, 0 is 2. Because for any quadratic, we'll have 2 solutions. If it crosses it, we technically consider that an odd multiplicity. It has an odd number of zeros there. So for most, the ones that we'll look at here, it's only going to have 1. And technically, I mean, depending on the formula or the equation, we could have 3. But if it crosses it, it's odd. If it doesn't, it's considered even. But we'll get more into that in the next chapter when we start looking at higher degree polynomial functions. Any other questions on these so far? So if we look at this next one, x squared minus 8x plus 12. So again, we can hit y equals. And clear this out. We can say x squared minus 8x plus 12 and hit graph. Now on this one here, we see it does cross the graph at 2 spots, yes? And the 2 points it crosses are? And we can go second table and look. Okay, it does cross at 2 because we have 2, 0, and 6, 0. So we can say x is equal to 2, comma 6. Because we can put a comma between it, and it's still the same thing as saying x equals 2 and x equals 6. And again, if you feel the numbers look weird, plug it back in. Because we could say 2 squared minus 8 times 2 plus 12. 2 squared is 4 minus 16 plus 4 minus 16 is negative 12, and negative 12 plus 12 is, we can plug it back in. Questions on any of these here? Negative 1, or sorry, not negative, 1 half x squared equals 6x minus 20. What? Yeah. we can subtract the 1/2 x squared, because these here will give us 0 is equal to negative 1/2 x squared plus 6x minus 20. Now, when we were factoring, we wanted the term in front of x squared to be positive. But here, the graphing calculator, does it really care if it's positive or negative? No. So it's still going to take it as this is here. So in the calculator, we can hit y equals, clear this out. We can say negative. A fraction, we can do alpha y equals, enter, 1 over 2. And then x squared. Which one? Okay, I thought you were saying it wasn't doing a fraction. Plus 6x minus 20, yes? That's the function. And if we hit graph, it doesn't cross the x-axis, does it? But that's fine. It just tells us that this here has what? Almost no real solutions. No real solutions. Because again, as I said earlier, every quadratic has 2 solutions. This one here still has 2 solutions. They are just not real solutions. And we talked about this in chapter 1, that there are such things as not real numbers. And once we cover those kind of numbers, then we'll come back to problems like this here and solve it. But what that also means is that graphing won't solve every quadratic. It'll solve some, and it'll give us the answers, and it's kind of nice. But it won't do them all, because if it doesn't cross the x-axis, we can't find the solutions by graphing. It's not that it's fractions, because I mean I can multiply through by 2. If we multiply the whole thing by 2, and whenever you have fractions or decimals, you can use a scalar to fix it. 2 times 0 is 0. 2 times negative 1/2 is negative x squared plus 12x minus 40. And I can come back here, and I can go down 1. So negative x squared plus 12x minus 40 and hit graph. It changed the numbers. It won't change the intercepts, but it does change the numbers, and it still doesn't work. Because even if we tried to find factors with it, it won't work. So this here doesn't have, neither one of these has real solutions. Let's look at the next one. 4x squared minus 12x plus 9. So again, it is equal to 0, so we can graph it. So I'll clear both of these out. So 4x squared minus 12x plus 9. Graph. We do see that it does at least touch the x-axis, yes? What number does it touch it at? So if we looked at the table, it's between 1 and 2. It's between 1 and 2, yes? Well, it really doesn't let us get to it. So, I mean, if it's not a nice whole number, it's not easy to get it with graphing.
I think it's about 1/2.
Now, I can show you all this here. If you go second trace will let us calculate a value. Trace, enter. And what this lets us do is plug in a value for x. So we could try 1.5. And that is 0. And this works nice for this here, but if we start getting irrational numbers, so say the square root of 3, because the square root of 3 is not a nice number, it's going to be very difficult to get it on the graphing calculator. And especially when we start looking at those kind of values, we'd have to almost know what the approximation of the square root of 3 is to use it to get there. Does that make sense? But this one here, we can look at it and see, does this factor? Well, there's no greatest common factor. But the third term is positive, so the signs are the same and they match the sign of the middle term, which is negative and negative. Factors of the first and third term. Let's use 2 and 2. Because when we looked at the graph, it just touched the x-axis, yes? So how many solutions should we have? 2, but how many unique? 1, because that was the only spot, right? So most likely, and this is more once you've done enough for kind of interpreting what's most likely going to happen, these are probably going to be the same. And we'll use 3 and 3. But again, that's just a guess. And we can check to make sure, because we can check this. Check the middle term. 2x times negative 3 is negative. So negative 3 times 2x is negative, which gives us, which is what we wanted, yes? So one of these two has to be 0, yes? So we're saying 2x minus 3 is 0, yes? Or, aren't those the same thing? So here, we can add 3, which tells us 2x is equal to 3. So we get 1.5 or 3/2, yes? Isn't that the value we found? I mean, we can do the same thing on the other side. How many values did we get? 2, yes? We got 1.5 and 1.5, the same thing, yes? So how many unique solutions do we have? 1. But we actually have the same thing with negative 1 on the first one. If we factored it out, we would have gotten x plus 1 times x plus 1, which gives us negative 1 and negative 1. And that's it. Questions on this here? Halves, or we could say x equals 1.5. We don't have to list both. We can if we want. But we can also just list it as 1.5 or 3/2. I will take either version. I would stick with fractions if we have not nice numbers. So 0.3 repeated, or if we start getting repeated numbers or stuff like that, I would keep it as a fraction. If we get radical answers, so square root of 3, I'd leave it as square root of 3, not as 1 point in our decimal version. Any other questions? Are we ready for the other type? But before we get there, we can see that graphing works well in certain cases, yes? Factoring works well as long as it's factorable. If it's not factorable, then that one doesn't work. So the few methods we've learned so far work in certain cases. So what is this one? So this one here we're solving by the square root method. That's the other method we have. Now the square root method works well if we don't have a middle term, we don't have x by itself, or we have a set of parentheses that's being squared. So something like this here, where inside the parentheses is the only place where the variable appears. If x is only in those parentheses, or like this one here, it's by itself, we only have x squared, we can use what we call the square root method. And the first step in the square root method is to get x squared, or the parentheses that are being squared by itself. By itself. And we're not really concerned, especially when we have parentheses, what's inside the parentheses. We just want them by themselves. We want them by themselves. So if we look at this problem here, what's the first thing we can do to get x squared by itself? We can add 31 to both sides. Because negative 31 plus 31 is 0. Which leaves us with 4x squared equals 49 plus 31 is 80. Is x squared by itself? Because is x squared by itself? No, it has what? The 4, yes? So we would divide both sides by 4. Because we want x squared 20. Now what do we do next? Square root. Because that's why it's called square root method. We square root both sides. Yes. Because the square root of x squared is x is equal to. And this here, square root of 20, a lot of these here, it's going to be nicer to plug it into the 30xs, the yellow calculator, because it will reduce in radical form. The graphing calculator is going to leave it in decimal form. It will simplify down to decimal form every single time. 2 square root of 5, yes? You have one of the two answers. Because we need plus or minus. Now the third step is to solve for x if x is not by itself. Now we do need the plus or minus. Because here, I'm going to just show it to y'all. Because if we said 2 second square root of 5. And we're saying that if we square this, we get what? 20, yes? Let's try this. Say negative 2 square root of 5 squared. We get? Since we times a negative by negative, it becomes positive. So really what we're saying in the step before, whatever number is here, when we square it, we get 20. So the number that's inside of x could be positive or negative, because when we square a negative, it becomes positive. If we square a positive, it stays positive. So if we square root both sides, we have to add the plus or minus.
So for all of the square roots, we have to always add the plus or minus.
If we square root both sides, we have to add the plus or minus. If we square both sides, we apply a second power to both sides, we don't. It's only when we square root. Because what is happening here? We're saying that this x is being squared. What's inside of it could be plus, positive, or negative. If we're taking, say, the square root of x, well, the number inside that root has to be positive. So we don't have to add it when we go the other way. Yeah, so when we square root both sides, we have to add the plus or minus. And now this method works for others because we could have x cubed equals 20, and we wouldn't take the square root, we would take the cubed root. So we can do this with higher powers. Let's look at this one here. So what would we need to do first? Yes. Which tells us that 3x squared is equal to x squared is equal to. Now what do we do? which tells us x is equal to almost positive or negative 3. So instead of listing it as x equals the square root of 3, comma, negative square root of 3, we can rewrite it as this here, because it's positive or negative square root 3. X is already by itself, so that's our answer. Questions on any of this here? Now we can look at the graph of this one, 3x squared minus 9, y equals 3x squared minus 9. Graph. We see that it does cross two spots, yes? One's positive, one's negative. Now I can go second calculate value, and I can say second square root 3, and it tells me that it is 0. Calculate value, negative second square root 3, it's also 0. So we can plug that back into the function, 3x squared minus 9, solve it, and it will tell us that it is 0. And that's one nice thing, especially with any of these here when we solve these. If you're not sure about your answers, plug them back in. Plug them back into the original function and see, does it equal 0? Or if we have stuff on either side, do both sides equal the same thing? Questions on this here? Let's look at the next one. Now this one here, we don't just have an x squared, do we? No, we have a set of parentheses, yes? But is there a variable anywhere else besides inside those parentheses? No. So we can still use the square root method on it. We just need to get the parentheses by themselves. We don't care about what's inside at this point. So the 2/5 and the parentheses are being what? So we can divide, or we can multiply by its reciprocal. So I can multiply it by 5/2, or I can divide both sides by 2/5, because these would telling me that x plus 3 squared is equal to, we can type that in a calculator. We can do 5 over 2/5 and get 25 over 2. Now with all these here, especially if we know we're going to have to take a square root eventually, it's going to be better to leave these as a fraction, not as a decimal. Questions on this so far? Well, is the set of parentheses by themselves? Is there anything being multiplied by in front of the parentheses? Is there anything being added to the parentheses? Well, we have the plus 3 inside, yes? Is anything added outside? No. Because again, the plus 3 inside's fine. Because here, the radical and 2 would cancel. If I had parentheses x plus 3, close parentheses squared, plus 4, had plus 4 outside of it, then we would need to get rid of the plus 4. But here, the radical and that square are going to simplify, leaving us with x plus 3 equals. Again, we have to include our plus or minus. Now we can try plugging the square root of 25 over 2 in the calculator. 3.55 decimal, and it won't put it back. So what we can do for this here is split it up. And in the yellow calculator, type it in as the square root of 25 over the square root of 2. Because with our radicals, we can break it up. And we'll want to use the 30xs for this, for the other one, not the graphing. And do the square root of 25 over the square root of 2. So 2 over 2. And this here is in simplest radical form. And at this point, on all the problems that we've done up to this point, x was by itself and we're done, yes? Is x by itself? No, we have x plus 3, right? So how can we get x by itself? Subtract 3. Now, is 5 square root of 2 over 2, is that a nice number? Is that a rational number? No, it's irrational. Is it have any like terms with negative 3? No, because if they were, they would need to both have the square root of 2. So we can leave it as negative 3 plus or minus 5 square root of 2 over 2. And if you wanted to, you could try subtracting 3 from it and see what you get, and it'll tell you that it's negative 6 plus 5 square root of 2 or 5 square root of 2 minus 6. They're not like terms. You just combined them into one. But that right there is our answer. Questions on any of this here? We'll start with this one tomorrow.